Hi everyone. Today I will introduce the project named BEIJING Site Air Quality Analysis and Application Development. The settings of analysis for this work involve looking at the data obtained from the different stations in Beijing for air quality that predict initial data cleaning, analysis and modeling, coding and version management using programming language, data analysis and software application development and version control software using Python programming language, Git and GitHub respectively. During the presentation, I will focus on such aspects as the process which will conduct the project main finding and the difficulties which were made. My second side, data handling. First up the project was the important and deal with the dataset provide hourly air quality data from the 12 station Beijing year by year from March 2013 to February 2017. The dataset including 6K pollution, the chemical component including particular matter namely PM2.5 and PM10, sulfur dioxide, nitrogen dioxide, carbon monoxide, and ozone gas. Daily average, maximum and minimum temperature, wind speed, and pressure. In this study, the 12 datasets were read in the Python environment situated in the Pandas library. Every dataset was analyzed with the reference of the how dataset should structurally similar, much in number of columns. These data, etc., following uh, show the dataset are validated. The dataset are amalgamated through the generation a dataset of 382,168 row in 18 column. The address in missing value data quality were perceived in following manner. In continuously area measurement in understood the missing value is temperature, wind speed omitted by applying mean impressions, while categorical data field such wind directions omitted has been applying mood impressions. Furthermore, a new daytime column was generated using the year, month, daily, and hour to facilitate more effectively temporal evaluations and time series modeling. Move on next slide. Challenging in the data handling. While performance data handling, certain challenges were noticed. Of them, the most important problem was that the dataset contains missing value, particularly significant parameters such as PM2.5 and methodological variable. The lack of PM2.5 value introduced inconsistently in the dataset, while lack temperature and wind speed detail introduced some systematic break. One of the different difficulties was the creation of the coffee record, which emerged as a result improper data merge. Had these duplications been left of the domain, the result, the entire research would have been beside. Finally, formatting in the dataset was also different where different conversations was used in naming of the columns, and there is a offer variation in the structure. To address these issue, I use mean and mode impressions in order to deal with missing value. Some with same record was merged in order to clean the data and call header were aligned the old dataset. These preprocessing system lead of the accusations of clean non-suspect data that were appropriate for using analysis. Exploratory data EDA overview. After prepare the cleaning dataset, next process the EDA. The re- relationship relation of performance EDA was get understanding of the trend of distribution and correlation existing between variable before deploying advanced model. EDA was performed using the main approach univariate analysis. Distribution pattern of the single variable were examined. Bivariate analysis compare pair of the example pollution in methodological condition. Multivariate analysis analyze the relationship between two or more variables at the same time through the heat map and correlation table. In these praise, simple visualization such as histogram, clutterplot, heat map were very useful. These were using for figure out trend of the instance of fluctuations in the level of the PM 2.5 during different seasons and associations between parameters of meteorological pollution data. Univariate analysis. In this first part of the analysis, which is a univariate analysis, I concern or look at the central tendency and distribution of PM 2.5, which in the variable in interest technical analysis suggests that the occurrence of the emissions were positively skewed with impulse that while affections from most of the time there were spike event association with high emission of PM 2.5 among the finding author point out the existence of the periodically with distant seasonal patterns. Another observations with that the PM 2.5 value were relationship higher when compared with the other seasons such as summer because of heat map disease unfavorable methodological reduce air circulation rate during the period. One of, one of on the other hand, result highlight that lower PM 2.5 occurred in the month of summer. In histogram provide useful illustrations in the fact of the given data following extreme risk group distribution with a beneficial identification PM 2.5 pollution pattern to be used when the construction model constructive model. Next part is bivariate analysis. Describing analysis of PM 2.5 was done establish correlation between PM 2.5 and each of the methodological variable that analysis demonstration and high negative correlation between PM 2.5 and temperature mean that the month of low temperature were characterized by higher concentration of the PM 2.5 likewise which velocity was significantly inverse with PM 2.5 in induction with wind play major factor for dilution pollution. The analysis also showed variation of the average of PM 2.5 across the monitor sessions and they illustrate in the from the box plot it was observed that station was the assessed location was industrial or a proper populated area in the module pollution was higher. To these, the methodology conduct a location were highlighted as factor affecting air quality and were informed the modeling. Multivariate analysis. The studies present more interact in relationship between variable given the multivariate analysis for the PM 2.5 demonstrate good positive relation with the other pollution like NO2 and SO2 may be due to similar sources like industrial emissions and vehicular pollutions. For the PM2.5 had a very strong relationship with the PM10 at 0.92, implying that two are frequently found the together environment and possible emitted from the same source. The relationship heat map offer all these in sum up manner from which were appropriate the predict bound of PM2.5 level in purpose was compare and evaluate further model development when making certain selections. Next slide is model building overview. The aim of the praise was perform machine learning of the forecast. The PM 2.5 level 2 model were implemented, and from the method we have both random forest regressions and linear regression. It starts with the further section in which leading predictors in including PM10, NO2 temp and SO2 were obtained. The data was had pre-processing through the normalization of numerical features and dataset and encoding of the sum of features, namely wind direction, which categorical data. Last but not the least, the data was pre-trained for 80% trained and 20% in order to evaluate the model. These measures would assure that all the models were trained on the stand and relationship data only. Random forecast, random forest result. Random forest model shown have very good result was able to predict level of PM2 point accurately. Key performance metric include R2 score is 0.896, suggesting that the model of explained 89.6% the variance is the PM 2.5 level. Mean square error 662.51. The text of further importance shown that the prediction was most inflated by PM10 than NO2, and temperature researchers have also appropriated the abilities of the random forest to address non-linearity and therefore prefers for modeling environment data. Linear regression result. Linear regression was moderate was performed the analysis but random forest surpass it. The key metric first auto score 0.854, mean square error 927 point. The lowest performed of the linear regression can be distanced soundly with the failure of the model of notice nonlinear regression in the dataset. The one shown that there the need to imply higher level models such as a random forest for environmental predictions. Next part is our application development, and for the increased functionality, a geo applications were implement in the Python Streamlit. The applications allow to use the required colored and clean data, should perform EDA and help the histogram, cutter plot, building development, and using model random forest and linear regressions. Through these design and interface, these web development applications PM 2.5 level can be free cross by general end user without any specific technical knowledge. Next slide is version control. At the level of version control, Git and GitHub was used these made it easy to track modification through the trace of data preprocessing, data exploration, analysis, modeling, building, and application development. The commitment and established as the working process was developed with a clear and comprehensive message from the committee. Circulation affections. Circular reflections sum up the proof that PM2.5 concentrations are highly depends on the seasonal and methodological mean. Random forest was that better model for the prediction of PM2.5 because it could capture higher order infraction. Different layers were associated with handling missing record duplicately of the records and inconsistently record format for the enhancement including incorporations the model in an actual time air quality measurement system as well including other predictive model of the enhancement that perform of the model. Thank you.